All right. Hey, everybody. Hope this is coming through okay. So here's the review guide for light. This is our second to last test. So we've got this one. We've got the next one, which is also light, but it's optics, how light goes through lenses and color and the colors we see in our human eye. Really, really awesome unit. Really fun. Pretty cool. Kind of how we experience the world. And then we're doing engineering with no test, and then there's a final with a test. So anyway, a quick little review of the equations here. First little section of electromagnetic spectrum. There's a couple equations in this. You definitely need to be able to use all of these. The first one, the fundamental wave equation, is pretty basic. Um, yeah, wavelength frequency is velocity. You need to know about light traveling. So velocity is distance over time here. And then this one is the velocity of light is c over n. This is not on your equation sheet. So this one right here is not on your equation sheet as this version. The version on your equation sheet is n equals c over v. But it's just a rearranged version of those two things. So, and then finally, what c is the speed of light in a vacuum, or really air, 3 times 10 to the 8 meters per second. And then once it goes into another material like glass or water or something like that, it's going to slow down. So it'll be less than this, but nothing's going to be faster than that. All right, reflection, super simple. Light bounces off things. 2 ways you can reflect. You can reflect specular or diffuse. And then the law, it comes in and it bounces away. And relative to the normal, those 2 angles are the same. That's it. All right. Refraction. Light slows down. Light changes speed. Again, the index of refraction is equal to c over v. That really should be in that one there. I don't know why it's not in that one. That's on your equation sheet that way, though. And then so it slows down. It changes speed. Wavelength gets shorter when it slows down. Frequency doesn't change. Frequency stays the same. And then again, oh yeah, all these things here, Snell's law, N1, N2, sine 1, or sine 2. That's how we tell about the bending of light there. But that's that whole idea of light comes in and relative to normal, rather than going straight, it bends down this way. So that's that bending of light, slowing down of light, changing wavelength, changing speed, not changing frequency. That is refraction. And then the next equation sheet, we get to diffraction and interference. This is that spreading out of light. This is the key equation you need to know for that. And again, remember, that's the kind of spacing between those dots there for the different pattern there. All right, then we shifted over to light as a particle and energy. Light, we can calculate the energy of light. So that's E equals H over F. And then E equals H over C. Again, these are 2 different equations here. You have equation 1 and equation 2 here. And then make sure you use the right H. This H goes in that one. HC goes in that one there. And finally, energy of light is energy. I don't know what that last one is. EF minus EI. Yeah, I don't know what that is. Energy of light. Yeah, don't know the other ones. Because the photoelectric effect is the next one, where the energy of the light is the work function and kinetic energy. And then fundamental frequency. I don't really do it that way. I believe the way it's written on your equation sheet says the kinetic energy of the electron is equal to the energy of light minus the work function. That's the simplest way, right? It's that whole like, you got like a well you need to get that electron out of. And so the work function is the energy needed to get it out of the well, right there at the top. And then the shoot away is the kinetic energy it's going to have. So the light you hit it with a photon is going to get it out, overcome the work, and then the leftover will be the kinetic energy there. And then the final little section there is all about redshift. So redshift, right? Redshift is the Big Bang. That's a key idea here. Redshift, all the galaxies are moving away from us. It gets redshifted. And in fact, sometimes it gets redshifted so much that it actually gets shifted down into the microwave range. And that's how we know the thing. So that's the introduction. I know probably a little bit longer than you thought. And question 1 will come up in the next video.